Well, hopefully we are running at the moment. Let me double check. And yeah, sorry about that. Technical issues as always. And I was planning to. Okay, good. Yeah, I was setting this up for ages, but of course it's not always working. Good. So, this about it. Okay. Great. It looks like we are working. Yeah, and latency is good as well. Well, everything seems to be fine. I will just open the stream on the tablet as well, so I can see if there will be any issue at all. So just one sec. Meanwhile, you can tell me if you can hear me. Okay. Good. The image quality looks a bit different, but well, should be fine. 1080, good. Be live, so yeah, you can hear me. That's good. Okay, so finally, yeah, that seems to be okay. Great. So, it's been 2 weeks, and finally I get my new Mac, as I was mentioning last time. So I decided to show you some cool features it can do now with the Xcode CreateML. And last time we was trying to take a couple of pictures of the Raspberry Pi and other electronics. It didn't go well really, so I would like to do the same today, start with the same today, although I will do it a bit differently. I will take just 10 pictures of each, and then we will not run it through the RoboFlow or Google Colab or anything. We will try to run it on the Xcode, which should be fairly fast, as this Mac has now this M1 processor, I mean M1 chip with all this GPU and neural engine on it. So as I was mentioning this last time, I had the data set of like 500 images before, and on my Mac, the old one, 5 years old Mac with CPU only, it would take like 38 hours or so, or maybe 36 hours. And with this laptop, it's going to take me only 4 hours if I want to do the same. So that's crazy fast. And now if I will take just 10 images of each of these boards, then it should take a couple of minutes only. And we can basically try it. And I will do myself smaller. And you should be able to see my screen. Good. Maybe one more adjustment. Give me a second. Okay, I'm back. You can see me better now. Great. So, what I want to do today is to open Xcode and go to the developer tools, CreateML. You probably can't see that, but it doesn't matter. And new document. And this is what we can see when we open up the CreateML within the Xcode. You have seen this before, of course. I was showing you this before, but now they added a couple of new things. Before we was trying image classification and object detection, and that's pretty cool, but now they added a lot of these and other things. I don't really know what they do, but definitely I will find out, and next time we can play around with it. But today I'm going to use again the object detection. and let's call it boards, documents. Okay, put it here, create, and that's it. But first, we will need to take a couple of pictures, and this time hopefully it will get better than last time. And not only that, what I'm going to do is I'm going to turn off this, and you can see now this is my iPhone, and with that I can take the pictures and you can see it real time. So I'm happy this is working now, and I'm just going to take a couple of the pictures, just 10 of them. I'm not going to do more because we don't have that much time, plus I'm pretty curious how well it will do only with 10 pictures. And I already forgot the count, but it doesn't matter because I can always check. All photos are 8, so let's say this is 9 and 10. Good. So now I should have 10 pictures of these. 9, 10. Good. And now just 10 pictures of the Raspberry Pi, and that's 1, 2, 3, 4, 5. Where was 5? 6, 7. I'm not sure. 8, 9, 10. I'm not sure if I'm correct, but let's double check. Okay, this one is kind of blurry. Okay, so just one more, and this. Good. Now I'm going to select these 10 photos. 10 plus 10, 20 pictures only. And if you see my face in here, I will explain that later, so don't worry why I took so many pictures of myself from that weird angle. I will explain. But now I'm just going to airdrop these 20 pictures, and I can start showing you. Yeah, here they are. So this is how does it look like when the airdrop is working, because that's not always true. And yeah, we have all these pictures now in here, and that's pretty awesome. Maybe I should put them in the folder. So 20 pictures, and let's call it boards. Good. Now I'm going for Rect Label. It's pretty awesome software, and as you can see, I was doing some traffic signs, and I will mention that later on as well. But for now, I'm just going to go to boards directory as well. 1 second. Good. And now we can label them. So 1, click, motor board. Good. Save, next. Click, motorboard, save. I should still, probably I should find out what's the name of the board anyway, but doesn't really matter now. I'll just call it motorboard, like this. I never tried with just a few images like now, but it can be interesting to see how well it will perform. And click. Like this. Good. So this is basically, it's not the perfect, but whatever. And this is Raspberry Pi 0W, but I'm just going to call it Raspberry, or maybe Raspberry Pi. No, Pi. Good. Save. Next. Good. Yeah, and this is just 10 images of each class. So I hope it will train within a few minutes. I never tried before, but I believe so. And good. Yeah, I started kind of right away today because there is a lot I want to show you. So the intro wasn't really overwhelming, but I just want to jump on it straight away. Okay, so that's 20 pictures. All of them are how we call it, labeled. And now we just need to, it's fine, because if you take a look on the board, you have the image and the XML file with the location, with the coordinates of the boundings. So that's fine, but for the Xcode CreateML, we will need to click on export and export XML files to create ML JSON file, because instead of many XML files, Xcode is using just one JSON file for all. So I'm just going to do that, save, and now if we take a look, we can see here's just this one annotation file with all the details. And only thing I need to do now is go back to here where we created this new project, and basically I just need to drag and drop this folder in it. So it's showing me these two classes, 20 items, validation data, I'm going to leave it on the auto, and testing data we can do that later. And now, as I was mentioning in the description of the meetup, basically you can choose between transfer learning and full network. As I understand, it doesn't matter much now, because let's start with the full network and we'll see how it will go. As we have only a few classes, I'm going to leave this on auto as well. For example, this is going to do 1000 iterations, but for example, with this data set I had 500 plus minus images. It was going to it was doing like 7000 iterations. I'm going to leave everything on the auto, so basically I just drag and drop and I can click the train. And this is why I love the Xcode, and I mean everything from the Apple, because they made everything just so simple. I don't need to dig into the code, bother with moving up and down all these folders and create data sets on specific directories and everything. So I'm pretty happy about this, and hopefully this will take just a few minutes. Yes, so we can see. Yeah, I'm going to leave it as it is, and this is going to train 1000 iterations. So in the worst case, we can just click on the snapshot and catch the latest working one, but it shouldn't take so long, so I'm going to leave it. And as you can see, we have pretty bad loss at the moment, but after a few minutes it will just drop down and it should be fine. I'm thinking now if we should just wait, or meanwhile we can do something else, and probably that's what we are going to do. I'm going to close this. I'm going to leave this run, and maybe I can talk you a little bit. I can tell you a little bit about the project that I was mentioning, because according to this, when I realized you can do the full network training on the Xcode, I was thinking of some new project, and this is what I'm going to tell you now. I was thinking about the indoor navigation, right? And there are some solutions for the indoor navigation. And let's just take a look. Indoor navigation. And if we take a look in here, there are wireless technologies, and you can use the Wi-Fi for the positioning, Bluetooth, NFC, create concept. Well, there are many different, and this is not exactly what I was looking for, but there are many different approaches how you can do that, because as you know, GPS is not working inside, and that's a kind of a problem if you want to navigate within the building. And so far there are a few solutions. As you can see here, I was playing with this one, but it wasn't bad really, and they are still promising there will be something new coming, but it's been a couple of years and I never ever seen it working really anywhere, and I believe it will, I mean, no doubt about that. But even Apple announced a couple of years ago the Indoor Maps program, and I'm not going to play this video. What I'm going to do is maybe just take a look at the photos, and they are using the Wi-Fi's as well, the existing Wi-Fi's, and then you can basically Wi-Fi determine the position of where the person is according to the strength of the signal, and that's basically the best approach so far, but it's still kind of really inaccurate, right? And there is also this Bluetooth technology, and that's terrible. If you ever work with the Bluetooth protocol, I mean, the Bluetooth is terrible by itself, and if you want to create navigation with the Bluetooth, I mean, it's just a mess. It's terrible. I was trying it myself, and I mean, Bluetooth positioning, that's just not working correctly. Then this different approach was to use the kind of object detection thing, or the AR, how they was calling it, not sure. So basically it can create you these nice arrows or line within the real world, what can be really cool, but it's working the way like you scan environment near you, and then it will determine the position where you are. Basically AR navigation, Google Maps. This is something what is actually working at the moment. You basically turn on the camera, scan your environment around you, all the buildings or anything. I was trying this in London, and as you scan some buildings, Google know from Google Street View where that building is. So then it can show you these nice floating arrows and take you to the right place. And it's working quite well, but if you want to use the same approach for indoor navigation, well, you don't have any, you don't have much different walls everywhere. I mean, most of the offices look more or less the same, right? So, I mean, if you have maybe some artworks on the walls or something, then you can maybe do it that way, or some QR codes or so, but it doesn't really recognize where it is, where you are. It just determine your position during the scan, and then it just set up the layout and hope. I mean, it's kind of hard to explain, but then basically you're just following the arrows, and it is kind of just locked to the original position. Okay, doesn't matter. Well, I mean, this is working actually really great. If you just have Google Maps on your phone, you can try it by yourself. They also has this Fox, or when they was doing the demo, whatever, in 2016 or so. I'm not sure. But then they get rid of it because they said it was like kind of distracting people too much or something, so you don't have that anymore, but you have the arrows, and that's great. As I said, that's working fine outside, but that's not really working great inside. So it's still not solving much the indoor navigation. And okay, so this is training, nice. Well, what I was thinking, just for fun, like how would I solve the indoor navigation if I need to, right? And I was thinking, okay, I'm playing all the time with this object detection and basically the same what we are doing now at the moment. And I was thinking about with the iPhone, I was showing you last time probably this breakfast finder example, where you can use your iPhone and it will use the object detection so it can recognize the objects, right? Pretty standard stuff nowadays. But the good thing is you have access to the code, so you can change it as you like. And I was playing with it and I realized maybe, okay, I'm going to introduce you the concept what I was thinking. If you have some as you're walking around some building like the airport or a shopping center or the hotel or anything, you can turn on the app and it will show you the floor plan, right? Like kind of like in Harry Potter when they was looking at the map. And as you are holding your phone, you kind of can scan with the camera the floor. But I mean, on the floor you cannot really put any QR codes or anything because it will look weird, right? But also every phone nowadays have the front-facing camera. So the app can use the front-facing camera to scan the ceiling, right? And if you have some like QR codes or something on the ceiling, then you can determine the position of where you are depending on which QR code it will scan, right? But again, that will require the QR codes, and that's still pretty weird. So I was thinking maybe I was thinking about some marks what you cannot see by naked eye, and of course that's infrared light, right? So I was thinking maybe if for the concept, just to try it out, I will use the lasers. And when I was a kid, I used to have this red laser pointer, and you can screw on these caps with different animals or anything. So basically the laser pointer will project some kind of symbol like smiley face or dog or cat, or I don't even remember what everything was there. Probably everyone of you had something like this as a kid. So I was thinking, okay, if I can use the laser to project this image on the ceiling, then I can object detect it with the front camera of the phone. So I went to the Amazon and I get something like this, and this is just a normal laser, this red dot, as you can see, just a normal pointer, and in here you can switch between different images. And I'm thinking what will be the best if I show you, yeah, maybe like this. 1 second. Yeah, so probably you see now the dot, right? And if I switch it, yeah, you can't see it much, but this is a butterfly. Yeah, it's kind of too close, so you can't really see it well. And if I switch it like this, it will show me the smiley face. And I mean, it's blurry because it's not focused on there, but you get the idea. So basically, if I swap it again, it's star and so on, right? And then I was thinking, okay, maybe, I mean, this costs a couple of pounds, so I can try to make it work with this, right? And so for that I needed to have the object detection app running, and that's why I took a lot of pictures like this, all right, with my face looking terrible from the terrible angle, because that's how you hold your phone and look at it as on the map. So I took a couple of pictures with different symbols on the ceiling, right? I'm not sure if I'm explaining this correctly, but I took like 100 pictures of myself walking around the house and projecting the symbols from this laser to the ceiling. And when I had like 100 pictures like this, and it doesn't really matter, no one will ever see these pictures, of course, just now as I'm showing you, but it will be part of the algorithm. And my face is important to have there because it will not, so basically it will know that's not important, it just should focus on the symbols, right? Maybe I should take more samples with more people, but that's basically just for testing it out. And I label them, of course, like this is the smiley face, this is the star, and so on. And then imagine within the building you have many different lasers, and they will point out to the ceiling different symbols. So when you're walking around with your app, it will scan the ceiling, so it can tell wherever you are. Now, this means all the ceiling will have some funny symbols on it, right? And that's true, but you don't really need to use the red laser. You can use the infrared laser, so it will be invisible to the human eye. So within your building, there can be tens or hundreds of symbols on your ceiling, and no one will see them. But your front-facing camera on the phone will, because front-facing cameras usually don't have infra filter. For example, iPhones, they have the infra filter on the rear ones, on the back cameras, so they cannot see the infrared, but the front-facing camera can. And I'm going to show you that because I'm going to bring a TV remote. Give me 1 second. Okay, so I'm going to show you my iPhone again. Just 1 sec. Yeah, here we go. And when I turn the rear camera and point the TV remote, you cannot see nothing, right? Nothing special. But when I will use the front-facing camera, here I am, and I will do this. Have you seen that? This is the infrared diode. When I push the button, it starts transmitting, right? And this is the same principle I will like to use with laser, because maybe I can show you now. Yeah, I'm going to show you. So this, for example, 1 sec. So here you can see the butterfly, right? Here's the smiley face, here's the star, here's mouse, and so on. Yeah, I mean there's just 4 of them. And if they are on the ceiling, you can see the symbol on the ceiling, right? And one bit of my hat. And imagine, so this is, for example, my office. So here can be stars on the roof, on the ceiling, and then, for example, in the living room there can be the smiley face, right? And as I said, this is visible for a naked eye, but if exactly the same is infrared, then I cannot see it, but the camera can. And I'm still waiting for my infrared laser because I don't have one, and I ordered one but they don't have it in the UK, so I needed to order it from China, and that means I just need to wait for it. And I ordered it like a couple of weeks ago, but probably it will take a couple more because of the Brexit and stuff, right? Now, so I'm going to play with the red one because I have it at the moment. And I don't have the infra, but it doesn't really matter because at least I can try it out with this red laser, right? And so I took a couple of, I think like 100 or 200 pictures or something like that. No, I think maybe more, 500 pictures, yeah, as I mentioned, like this, just with random weird angle. Because as you are walking with your phone and looking at the map, you are or holding the phone flat or kind of tilted to your face. So it still can scan the ceiling behind you. And if there are these symbols, then obviously it can read what that symbol means, and according to that it can determine the position on the map where you are. And for that reason I made this floor plan today, and this is my my flat. And as you can see, actually I was doing this with the app called it was pretty cool because originally I wanted to measure it myself, but then I find the app called Magic Plan, and basically it was using the augmented reality. I was just basically with the camera putting the corners and everything, and it just drew it all by itself. Pretty cool stuff. So basically this is my flat, and imagine like as you see my cursor, like the point, the cross. So imagine I can see this on the phone, and let's say in here I will have the blue dot, yeah, or somewhere where I am standing, because it will scan the ceiling with some symbol, or maybe don't need to be like smiley face or star or anything. It can be the actual QR code or something, because you can use the laser to project anything really. So it can tell you are standing here. If you will move, for example, in here, the center of the living room, it can scan the symbol there, so it will move your dot into the living room. And if you are as you are walking, it can show you basically where you are and maybe like where you want to go and something. So in the workshop, for example, there can be stars. In the bedroom, there can be smiley faces. In the bathroom, there can be whatever was the other ones, right? And this is just for the testing out, really, because there are a couple of problems. But doesn't matter. I mean, that's something what we can try. Why do you prefer to use lasers as opposed to the example stickers and QR codes? Yeah, yeah, that's true. And mobiles can see the infrared. Yeah, of course. Why I'm talking about the lasers is because you can make them invisible. If they are infrared, there will be kind of, if you have the stickers of the QR codes, you can see the QR codes, and it doesn't really look good if you are somewhere and you have hundreds of QR codes stick to the ceiling. It will work probably, of course, but with the lasers I was talking because you can make them infrared, so no one will see them. So you have the laser somewhere on the next to the wall, for example, on the floor, like small device, and then it can project to the ceiling. As I mentioned, there are a couple of problems. You will need to have a couple of hundreds of lasers, and they need to be connected to the power, right? But I said that just because that's just for the testing, right? That's just like the prototype solution. Then there are, I will talk soon about different approaches which can be battery operated. But for now, imagine we are going to use the lasers, right? Not the most effective solution, I know, but as I said, we can make them invisible to the naked eye. So, and your phone will still see it. And so I made this floor plan, and so this is training. Good, I'm going to leave it like that. Well, basically, what we can do is download this example, and that's what I did earlier. Jesus, my English term. Once again. So I just have it here. Okay. And this is the example from the internet, and I'm going to delete this because we don't need this. And what I did earlier, right? I believe I somewhere have the doesn't matter. If not, I will because I trained it before, so I should somewhere have no, not here. I should somewhere have the model I trained before. Just 1 second. If no, we can train it again, at least for a bit. Maybe I deleted it. Not sure. Okay, doesn't matter. Well, basically, we can just try with the default object detector model. What will recognize bagel, banana, coffee, croissant, egg, and waffle. And if I will select my phone and put it in, yeah, I'm just going to put it to the default because I was playing with it before. So it will use this model run, and I will show you my phone now. Okay, unblock the phone. And good, I'm going to so this is the app, and if I will search for some bananas, unnecessary PNG, yeah, so this is just running out of my phone, and as you can see, croissant, yeah, so it's running pretty well, right? And the same I want to use for scanning the ceiling. And what was there? Coffee, right? Coffee. And what was the other ones? Eggs. Let's try egg. Yeah, so we have some eggs in here and waffles. Good. So it's just detecting the objects, and this is default example from the Apple, right? And well, I train it for recognizing my laser images, these star and smiley face, and I cannot find a model at the moment, but doesn't matter. What I need to do is to switch this rear-facing camera to the front one, and of course I'm not really a good coder or anything, but I figure out it's fairly easy. I was thinking, okay, I don't know how to do that, of course, but I can imagine it will be somewhere in here. So I started to search for back, and here you can see the position back, and if you switch it to the position front, it's going to use the front camera. So that was fairly easy, right? And give me a second. Okay, so now here we go. We are using, okay, I'm not the banana, come on. But okay. this is the front facing camera now, and if we are going to point it like this, it will recognize the objects, right? And that's good. So now as I'm walking around, it can scan the ceiling, right? I mean, it's scanning nothing right now, but imagine on the ceiling there is a banana symbol. Right, something like that. It will maybe, yeah. Doesn't matter. I want to show you this example with the laser, but I need to find this model first. Anyway, so that's the first thing. We needed the front-facing camera. We have that. That's great. And also, we need to recognize the objects. What we are going to do in a moment. That's fine. So we need to create another Mlm model, but we can do that. That's fine because I have the images like this, as I was showing you, and I have them labeled, so we don't need to do that now. And then you can think of putting the floor plan, right, on top of that camera view. So if you are going in here, this is the launch screen, and this is the main. So basically this is where the camera is showing what's going on. But if we will put on top of that image, and that image will be the floor plan, then basically something like this. So then when you will run the app, you will not see the camera at all, right? You will see only this. So when you run the app, you will see only this, but under this, the camera will recognize the symbols. And then you can make some fairly simple if-else condition saying like, if you recognize smiley face, put the blue dot in the living room. If you recognize star, put the dot in the workshop, and so on, right? So you will never see the camera actually. You will see always just the floor plan, for example, and then your position where you are, depending on what's on the ceiling. And I mean, this is demo, what can be put together within one evening. If you know how to do it, because I still didn't figure out how I can actually put this over the, basically what I need to do is, as you see, I put this logo in here. So I just need to put the image layer on top of the camera, what I think I just did in here, but when I run it, it's just not working because I honestly don't know how to use the Xcode much, and as I said, I'm not really a coder, and I'm still confused. I'm just still a beginner, but I will need to find out how I can do that, because when I run this now, I still can see the camera, right? I don't have the image in there, and I'm not sure how to do it, but it should show me this, but it's still showing me the camera. And I'm pretty sure there will be some easy fix. I just need to somehow probably move this somewhere, or I don't know, I was trying anything, but I just didn't figure it out. How can I do that? But once I will figure it out, then it means it's 95% done. And then I just need another image, this blue dot icon, and just make the code to move the blue dot wherever it's scanning, right? And that's my simple idea of the using lasers for the indoor navigation. And as I was saying, this will require tons of lasers and all of them need to be connected to the power, right? And then I was thinking, if you have the green laser, you have these, you can play with the something like this, what is creating the patterns. So yeah, something like this. So imagine in each room you have just one laser, infrared of course, but imagine now it's green, and it will basically illuminate all the ceiling and surrounding walls with some kind of pattern. And then you can basically, the camera can just recognize the pattern. So you don't need to have like 20 lasers in one room. You can have just one laser in one room, still connected to the power, but only one, and each room will have different pattern, right? That's fine. That will solve the issue, kind of. You see, you can have different patterns like this, and or still maybe can be QR codes or whatever. I mean, fair enough. And I didn't try this yet, but maybe it can be another good example. Yeah, for example, here you can see different patterns, and again, if the camera will recognize this one, you are in the living room. If this one, you are in the bathroom or whatever, right? Sorry. And that will work unless we may have also another solution, and another solution will be not to use lasers at all, but just LEDs, right? And when you have the LED, it's of course you know what LED is, everyone knows, but you can have the infra, right? Basically exactly the same I show you on the remote controller. And good thing about LEDs are you can make them blink, and if you can make them blink, you can make them blink the patterns. Exactly the same as the remote controller I was showing you. When I was doing that, it was blinking some kind of frequency, and the TV will recognize that. Now, if we take a look in here, and also they can be battery powered, right? So if we will go to Oculus LED camera, I'm not sure how can I search for it, but there's one guy kind of hacking the Oculus. Anyway, so imagine instead of the lasers, they can be just these small LED boxes on the ceiling, like glue on some small box, like box of matches, kind of, with the battery and LED in it, and you can glue it on the ceiling. And for that, then you don't need to have any power, just the battery. It can be battery operated, and it can last for a couple of months, I believe. And then again, you are just going around with your phone, and the phone can recognize the blinking pattern, right? Again, you cannot see anything by the naked eye because it's infrared, but the phone can see, okay, there is a LED, it's blinking, I am living room, so I am in the living room, right? And well, I'm not sure. Yeah, the Oculus is using the same kind of technology. It's just basically blinking LEDs, but I hope I can find the video I'm looking for. So yeah, this is fine. This is how does it look like, but now you see it's just like blinking, but the point is every single LED is blinking in a different frequency, and the camera can tell which LED is which. And it was OpenCV, and yeah, I was planning to use the OpenCV for that, because then I was thinking if there will be another problem with the I mean, if you probably want to use the camera and the OpenCV to recognize the pattern in the remote controller, that will be probably too fast. But the good thing is you can specify how fast it will blink and what it will blink, right? So that's why I can't find it now. That's kind of stupid. Because there was pretty awesome example. One guy hacked it together, and he was basically determining each LED on it. And if I will not be able to find it, that's kind of stupid. camera LED frequency. Yeah, of course I couldn't find it now. Anyway, I'm not going to spend any more time on this. There is also, okay, I can't find it anyway. There's some guy who was asking more or less the same thing, but basically with the camera you can find out which LED is which depending on how fast it is blinking, right? And just one more second. Yeah, so basically this is here on GitHub, some guy put this, it will find the blinking frequency using your webcam. And well, I don't know how to run it because I don't know how to run the C code. So I was trying to make it run, but I wasn't able to. So if you are able to make it run, just let me know, because it can be pretty awesome, because this will basically solve my issue. But even if now, I will probably just put something together, and instead of the lasers, what are kind of power hungry, I can use LED, kind of stick it to the ceiling, and you can have thousands of them. Doesn't matter, because it costs like £1 or something per this small device, right? So you can put them everywhere you want, and then it can just recognize the blinking and it tell you where you are. I'm going to quickly, one second, I'm going to turn this off. I'm going to see, because also I was talking about this floor plan with the blue dot on it, like, but also the same way you can use a 3D view, right? Because look, this is the Magic Plan app I was mentioning. Not only it created me this nice floor plan, it created me also this 3D view, and that's pretty amazing. Of course, it's not 100% accurate. It took me like 10 minutes to do it, and that is pretty cool because I didn't measure anything. I was just walking around with my phone, pretty awesome stuff, right? And if you can have this and you know your position because the laser or the LED tell the phone where you are, you can basically do something like this. Or next step, it can be indoor navigation AR. So basically, thanks to that, you can do something like this. Yeah, you can add the augmented reality into the real space. What I don't know how to do at the moment, and that's not even really important, but as you can say where the person is, because it's scanning the symbols on the ceiling or QR codes on the ceiling or whatever, but they are invisible to the human eye, then you can do any kind of indoor navigation. And now, I don't know, maybe it's stupid and it will never work because of something, but I don't know. I mean, it's just an idea how to use the object detection I was playing with on the Xcode, and it's fairly simple to do so. You just basically put the images in there, change the camera to the front, just drag and drop kind of this floor plan, and more or less that's it. Yeah, that's like one evening and it's done. Unfortunately, I don't have enough experience with Xcode, so I don't know how to make this floor plan visible over the camera, but I will just probably find someone who knows Xcode, and I believe he will help me out in 5 seconds. And once I will have this, it means I can put the picture on top of the image, like I was doing in here. So if I can kind of put this image on top of the camera, that's I almost win, right? Because that's the only thing I need. And then the blue dot, that can be PNG image, and I can move it around depending on the position or depending on the object what is scanned, on the symbol what is scanned, right? So it can be lasers, it can be like QR codes and lasers, or it can be LEDs, right? And basically the whole idea behind this is to scan the ceiling with the front camera, because the front cameras on the phones does not have the infrared filters. And for example, my Samsung Galaxy Note 10 Plus 5G phone, it doesn't have infra filter even on the back camera, but for example the iPhone, it does. So that's why I was thinking about to use the front-facing camera, the selfie camera, because it will always be without the infrared filter, or I never ever met the phone with infrared filter on the front-facing camera. And thanks to that, it can work on any phone really. You just download the app. For example, if you arrive to the hotel, you download their app and you can scan, and you can just see where you are on the map. And that's pretty amazing. You don't need to know anything about how does it work, because you just walk around and it's showing you where you are. And it's so simple, it's so primitive. It can be done within one day, basically. I mean, the installation of the lasers or LEDs will take a while, but I mean, from the kind of coding perspective, it's something I was able to put myself together within a day. Except the last part, put the image on top of that, but that's just a stupid I'm not just sure how to do that, but still it's just like really a simple thing to do. And once I have that, hopefully by next time I can show you how does it work by walking around this, and hopefully by next time I will receive my infrared laser and I can show you how does it work, right? And again, maybe there is something out of there like that. I don't know. I didn't really check. Maybe there are more smarter people than me out there. So I believe someone get the same idea before. But I mean, I'm learning how to use the Xcode. So I was thinking, okay, this can be cool demonstration of object detection and CreateML and stuff. So I want to show you how it will recognize this red laser, because that's kind of nice to see. But first I need to finish this, and it will be done within a few minutes. Well, meanwhile, give me a sec. Yeah, so the same way how you are projecting the smiley face, you can project the QR code, for example, and if it's invisible, here we are, right? Again, it will be better with the LEDs probably, but I can't. Okay, maybe I will have it in the watch later. Give me a sec. I will quickly. Yeah, of course. Here we are. This is what I was talking about. So this guy, I don't know who he is, but he's pretty awesome. He puts together this thing, and as you see, it is showing him which LED is which, depending on how is it blinking on the Oculus. And you see, so this one is 525, this one is 205, 684, and basically he can determine the not the position, but the ID of that LED. And imagine, so one LED is on the living room, one LED is in the bathroom, blah blah blah, and you can have multiple LEDs, or they don't need to be LEDs. Maybe they can be like LED bulbs or something, right? So that can be pretty awesome to just walk around and see which one is which, and it can run out of the battery, right? Or it can use kind of the existing bulbs, so they can transmit normal light, but also the infrared on the specific frequency. So that's another approach. And then I forgot about the last one. You know, again, as a kid, you probably had the UV ink pen, invisible pen, something like this, right? And I was thinking about the same. Okay, some terrible ad. Okay, so you see, you have this invisible ink or invisible pen. Jesus Christ, that's awesome. Yes, so you know this one, right? Everyone was playing with it as a kid, and I was thinking about, okay, the ultraviolet. Of course, I cannot use that, but if there is something like this invisible ink for the infrared, so infrared invisible ink, and I find out there actually is one. And if you go, yeah, this one, and how can I see that? There was actually online store. They are actually selling them for like $20 or something, or £20 or so. Magnetic ink. Okay, I can't find it now, but I'm pretty sure it was somewhere. So basically another idea was to don't use lasers, do not use LEDs, use just a infrared pen or ink or whatever it is, and paint the symbols on the ceiling with this special ink, right? So, and then I believe the camera will see them, but if not, you can add a couple of infrared light bulbs, and it will illuminate the room, and it will basically then show up these drawings, or they can be QR codes or symbols or anything, right? So you can have like kind of invisible graffiti on your ceiling, like all your ceiling can be full of some symbols or QR codes or anything. You will be not able to see them, and they will be just there thanks to this invisible ink. And that's good, because then you don't need to change the batteries, you don't need to plug anything to the power, maybe just one infrared bulb. But where I cannot see it here. But thanks to that, it can be kind of totally, I mean, without any external power. The thing is, Jesus, I never can find anything what I'm looking for. Let's go back. The disadvantage of this is, oh, here we go, finally. So you see, there is 840 nanometers or 885. I think this will be more visible because it's closer to the human range, or doesn't matter, right? So the thing is, maybe I can order one and try it out, paint something on my ceiling, and doesn't matter because I will be not able to see it anyway, and then try if the camera will catch it. If not, then I can try to light one infrared bulb somewhere in the room, and it should illuminate the ceiling, and then it should be able to read the symbol. And the thing is, that sounds like the best approach, but unfortunately somewhere they was mentioning it kind of fade out after a while, well, like after a few weeks or months. What is still probably good enough, but I can't really imagine to repaint every ceiling everywhere every few months. That can be kind of stupid. And especially if there is direct sunlight, it fades out much quicker. But again, this is like the third or fourth approach what you can use. Everything is the infrared and the camera with the object detection solution, and I think that can be pretty cool, any of these. First, I'm going to try just with the lasers. If it will work, then I will try with the LEDs. If it will work, I will try maybe this pen, or maybe this pen and then LEDs, doesn't matter. Yeah, the ink will last for months, but it will fade in the sunlight after 1 week. And this is kind of a problem, because if there are some windows and there is direct sunlight, or not direct, but there is sunlight, then it will fade out, and you know, that won't really help. So, but I mean, can be cool. I mean, I will probably just order this one pen. Maybe I should do it even now. We'll try to draw something on my ceiling and test it out. I mean, that's kind of worth £20 or so. So maybe I should do it. I'm not sure actually which one, if 840 or the 885, or this one maybe. Okay, I will check it out later. Because yeah, the infrared laser is on its way. I ordered it from the AliExpress, and let me check when it should arrive. Sign in. Because I mean, again, maybe I will find out it's this kind of stupid and not really will work or something, but I mean, even if no, at least I try to do something with the object detection, so I'm still learning stuff, and if it will help me to learn the Xcode, why not? I do not click on this. Okay, and if we go to my orders, and this, I ordered it when 15th of January, so that's quite a while ago. That's 2-3 weeks. Okay, maybe 1 more week and it will be here, but as I know, the customs is probably quite busy now, so maybe it will take a while. But if I will receive it by the next time we will have this meetup by next 2 weeks, then we can try it out and we will see how does it work. And by the time I hopefully figure out the floor plan, so hopefully by the next time I can show you working app. And again, I ordered just one laser, so I will kind of need to fake it because I'm not going to put like 10 lasers around my house. I'm going to do it with one and switch the symbols manually, but you will get the point anyway. If it will move the dot on the iPhone, then that's nice proof how does it work, right? And back to this. Yeah, we can try this. As you can see, it's going like this, and it's going down, and then it's going like this usually. But as we have only 10 images, the accuracy will be not perfect, but we can try those straight away. This is the evaluation, and in the preview I can drag and drop some images. You know what, I'm going to take the new images, so they will be different, and I'm going to show you my phone. I'm going to take few images. Good. I'm going to send them now. Select 9 photos, airdrop them. Okay, and now goat. Michael, you mean goat like greatest of all times, or goat as an animal? Because I'm not 100% sure. I'm going to take this, put it in here. Oh, you cannot see that. 1 second. Okay, so basically I'm going to do it again. So what I did only, close this, I'm going to take these images and put it in here. And now no object detected. Okay, that's kind of bad. Anyway, I'm going to get this, put it in the desktop, let's say, boards 1. I can close this. Like that. And I'm going to drag and drop this model in here. Good. And it's called boards 1, so I'm going to rename it in the code. And that's in front. Well, where we was changing that? Front. Yeah, I'm going to put this back to the back. And in here, I'm going to put this to the boards 1. Put it on my phone. And I believe this will be quite terrible because we have only 10 images of each class. And it will not work well, probably. Well, sorry. I'm going to show you what I can see on the phone. And as you can see, it is saying Raspberry Pi. But the bounding box is somehow wrong. I'm thinking if it's not because I put it on the wrong orientation or something. No. I mean, it's recognizing it correctly, but the bounding boxes are terrible. Let's try here. Yeah, this is motorboard. Something's wrong, and I'm not 100% sure what. It looks like maybe the orientation's not right. Let me try. Well, I did something wrong, definitely. I cannot change it anymore. Well, it's recognizing it correctly, so I'm happy. You see motorboard, just the bounding boxes are somehow wrong. Not sure, but not sure why that happened, but at least it's recognizing it correctly. Was great. Again, this is just with 10 images, so I didn't really expect to work it at all, but it was. Okay, that was just basically to see how it will run. But what I want to do is open this laser, and in the training, you see before I was training these laser things. It should be 7,000 iterations. I didn't have time for that because I was starting. Oh, yes, again, you cannot see my screen. 1 second, sorry. Yeah, here we go. So this is these laser symbols, and I didn't train it in full because I don't have time to do that because I started only at like 6 and at 7 I needed to start streaming, so I stopped it. But you can see in here I made 1,800 iterations. It's not much, but should be enough for us to try the laser. So I'm going to the output, get the code, get the model. Let's just call it laser. And as you can see, smiley face and star, these are 2 classes of my laser. So I'm going back to the code. I'm going to call it laser. And first of all, I need to put it in there. Laser.ml model. Done. And also I'm going to do the front camera. Save this, save that, and let's try to put it on my phone. I believe it will be not 100% accurate or anything close because it wasn't fully trained, but probably better than the Raspberry and stuff. Okay, so moment of truth. Here's my phone, here's the laser, and here is the star. And again, we have a problem with the bounding box. It's not correct at all. It's somehow wrong, but it's recognizing it correctly. And if I will switch it to the smiley face, it is recognizing the smiley face. What's pretty good. So star, smiley face, star, smiley face. Actually, it's working pretty good, except the bounding boxes are not correct, but that's probably just some bug. I need to find out what exactly is going on. So imagine you walk to the room. Okay, so I'm going to make the model situation here. I'm going to leave this in here on the yeah. So basically I walk into the room, and as I'm holding the phone and looking at the map, I cannot really see myself. This is just for demonstration purposes. It will recognize the smiley face on the ceiling, so it will know I am in the office. And if it will, then I will walk around to another room, and it will see the star in that room. It will know I'm in the, I don't know, living room or something, right? And the thing is, you are or holding your phone like this, like directly looking at it, right? So it will still see the star. So it will still see the symbol. It can be QR code, for example. Or you are holding the phone like this and looking directly to the map like this. So your fat face will cover a bit, but as you are walking, it doesn't matter much because the symbol will be still visible, right? That's why I was taking the pictures with my fat face, right? Because even if you're like this or that, or as you are walking through the corridor or something, it will pick up some of the symbols, so it will always tell you the location, right? And that's quite cool. I definitely need to find out what's going on with these bounding boxes, because they are definitely not around it, but at least they are picking it up correctly. So that's cool. And even if I hold the phone like this and there is some symbol like that, or it can be even the walls, not necessarily just the ceiling. That was the approach with the green laser, as there is a pattern, as I was mentioning. And you see this is now recognizing the smiley face. So you get the point. And obviously now I can see it because it's red. But if this is infrared laser, well, that can be pretty good because no one can see anything on the walls or on the ceiling, and your camera will still pick it up the same way we pick up this, right? So I'm pretty happy about it, although it wasn't fully trained. It was trained just 1,800 iterations, and I had around how many images? Let me see. 488 images. So this was training for how long? I started at 5:51, so plus minus within half an hour I was able to train 1,800 iterations, and that's only thanks to the M1 processor of this MacBook, because you see Apple M1, and that's pretty amazing, because otherwise on the older MacBooks, even more expensive MacBooks for like 5,000 or so, it will take like 36 hours or 28 hours or something like that. to make it full 7,000 iterations as I was trying last time. And in this laptop it took me just like 4 hours, so I'm going to leave it run through the night, or basically this evening, to fully train it. But first I need to figure out why the bounding boxes are not sitting correctly, but I can imagine that there'll be just some stupid issue like rotation of the images or anything like that. Or maybe I know why. Oh no, I don't. I was thinking it's maybe just mirrored. That may be it. Because as you were seeing, it's on the good location, but kind of like mirrored. So, but I'm thinking, how exactly is that possible, as it was doing even on the back camera, not only on the front. Doesn't matter, I will figure it out. That's just a small detail. So lasers, LEDs, or this invisible ink, I'm going to try all of them, but the code is going to be more or less the same all the time, right? The same way I will train the model, the same way I will edit the code, and I mean, that can be pretty awesome. I mean, I can have working app for the indoor navigation within few days or so. No, I just need to figure out the image overlay. Good. So that's yeah, for example, this was I was trying to, these are the 6 categories from the original model, and I was trying to detect the banana, and when the banana is there, then it will move the dot in there, and if it's detecting coffee, then it will detect the coffee. You get the point, right? Good. So this is it. And yeah, I was actually saying I will tell you the difference between the actually I call this meetup difference between the full network and transfer learning, and I didn't even mention that in here, but let's open this. How long does this take? About an hour. So let's try to do a duplicate of this, and let's try transfer learning, and I'm just curious if it will train faster or not. So we can leave it run. I close this, I close this, I close this, and I close this as well. And maybe, yeah, it looks like this may be faster. So that was plus minus 1 hour, or 1 hour and 10 minutes. And this one, well, maybe it will be faster. But as that's why I trained on the full network, because it basically, I have the option, that's first of all, but it kind of, if you, for example, take some model, pre-trained model, which one is recognizing the animals like cat and dog or anything, and you just want to add another animal, then you need to retrain the whole model, because it's easier than just to use the transfer learning, because it will be quicker and the model is already trained on the animals, so it's easier. But in this case, it's quite specific different of object I'm trying to detect, so that's why I make it this way, full network, just to be sure it will recognize it better. And it's taking longer, of course, but depends what are you doing, of course. As I mentioned before, in here I have these traffic signs, because yesterday I took my girlfriend and we was I was driving around Reading, and she was taking pictures of the traffic signs. And again, I was just drawing the bounding boxes around them and was hoping for the best when I hit the train. And it's working quite well. I mean, it recognizes them quite well, but if I open this and go to preview, it files, and traffic signs backup. So let's add a couple of these. Open, let's add a couple of 50s. So this is a model I was training yesterday, and let's add a couple of 40s. Yeah, and now you can see as I train it, it's actually quite fine, except for example this one is not correct because this is 30 not 20. Okay, let's go in here again, 20 40. Okay, 30 40. So as you see, for example, this one is nice, this is 100% confident, it's 50 50, good, 50, okay, that's good, 50, that's good, 50 40, this is good, but the box is wrong. 40, this is good. 40 40 and 40. This is actually quite good, but not perfect, of course. And on the image is working well, but once we can try it out. I will get it. I will save it to the desktop, this model, and we will put it on the iPhone. You will see. So this one is training, I will leave that, but now I will take the traffic model, put it in here, and rewrite this to traffic and put it on my phone. So we will use this. And why I wanted to do this, I think last time as I was mentioning the project, I want to put it in my car so it will show me the latest allowed speed, how fast I can go. Okay, so and I want to change also I don't want the front camera but the back one front. So in the back camera, good. I'm going to put it on my phone. Good. So, yeah, here we go. I can show you my phone again. And if I will put it in here, you see now the confidence is pretty good, it's 30. But that's because the sign is quite big. But if I will open this one, this 30 as well, that's fine. But as the small, okay, this 30 as well, that's good. 30 as well, okay. I want something different, 40, that's good. But you see now it's kind of jumping between 30 and 40. As I will go closer, it's going to be more confident. But as I'm getting more far, you see this is saying 30 and that's not correct. So it's working well unless you are a bit too far. You see this is 30, but if I will go closer, okay, this is 30 still, so this is not so good. I mean, it's doing pretty great job to saying where the sign is, to determine the location. But what is written inside it is not going really great job, because I had only, I think, 50 images per each, and that's not a lot. Plus, I think in this case, you see, it's working pretty good for the to determine the location, but it's going pretty terrible by saying what's in it. And that's why I was thinking maybe what I can do is to use the model not to train to the specific number, but use the model to train just to recognize where the traffic sign is. And once I will know that, I will have the four numbers, like where exactly the traffic sign is. Let me try one more. See, it's 30, but maybe if I will go closer, No, it's still saying 30. So maybe I can just use this to determine where exactly the traffic sign is, because they're doing a really great job. And then within that specific box, I can try to run the OCR, what is the object, sorry, 1 second, like this, optical OCR, optical characteristic recognition, right? Character recognition. And I tried it, but OCR is not working really well in this case, because there's more or less just for the printed text in the books and stuff. So that's why you have always the MNEST digits recognizer example. When you are learning machine learning, you will find out this, and this is basically the most simple convolutional network to recognize the handwritten digits. And I was thinking I can use this to read the numbers within the bounding box of the traffic sign, and this way I should be able to successfully read the traffic signs speed limits. Unfortunately, I have no idea how to do it yet. I'm really sure I will figure it out, but I know how to run this. I know how to run the object detection for the bounding boxes, and I just don't know how to combine them together. And that can be nice thing to figure out, because basically, if we go to Google Street View or just maps, so basically when I run it, let's go somewhere. Okay, this is another. Okay, where is this? This is nice. I should save that. Oh, okay. I will save the location because this looks cool. Anyway, let's go to some roads. Put it to some roads, and of course we don't have any speed limit in here. So let's try again. Maybe here. Jeez, how hard is to find traffic sign? Maybe here. I don't know, I just want some traffic sign. Oh, here we go. So, for example, I can have it in my car, and as the car will approach, it can use the same model I was just showing you to determine where exactly the traffic sign is. So it will make the bounding box with these 4 corners, and these are basically just the numbers of the pixels. And then within that, I can run another test to tell what is the number inside, right? And then I can be sure that 30, not like it was showing us on the iPhone a couple of minutes ago. And that can be pretty awesome as well. So these are just 2 projects to do with this indoor navigation and then this traffic signs recognition. And back to the transfer learning, it's saying it's iteration 500. So, and that was when I ran it was 26. Now, so within 10 minutes, we are in iteration 500. So that's 20 minutes plus minus to make it to full 1000. Well, that's what? 3 times faster than the full network, right? If the full network was 1 hour, this is 20 minutes, that's 1/3, right? And we can test out the performance within 10 minutes. And I believe it may be similar, because even the full network wasn't really good, because again, we have just 10 images. per each class, but I would take more. But if I want to stream this, obviously we don't have that much time to just run it. And I mean, again, this is awesome performance, because if I will run this on, I don't know, some even more expensive laptop from Apple from different years, it will take like 10 times longer at least. So it's running really fast, but still it's machine learning, so it's still taking time to train, of course. And if we take a look on the monitor, we may be able to see and of course I'm streaming as well at the same time, so that's not helping. But somewhere, how was I able to visualize GPU Apple monitor? How it was 1 second. Oh, of course. So in here, view GPU no. Oh, here we go. Show GPU history, and also view CPU usage and CPU load. No, I want all processes. Okay. Oh, here we go. GPU history and CPU history and CPU usage. Okay, so in here we can see this Mac has 8 cores, like 4 lower performance and 4 high performance cores for the CPU, and 8 cores GPU, and also this 16 cores neural engine. What is unfortunately not used at the moment for the training. Maybe they will add it later on, I'm not sure. But as you can see, all these 8 cores are running on the full capacity, and also the CPU, but that's also because of the OBS. I'm streaming to YouTube, so that's why as well. It's nice to see alongside with the iterations, and as I said, within few minutes we will see this model. What we was doing, it was transfer learning, and maybe we will see the difference, and maybe not, because again, as I said, this is just an image, 10 images per class. So meanwhile, you can tell me something on the chat, because I wasn't really paying much attention to the chat till now. So as we have a couple of minutes now, maybe you can tell me something nice, or maybe what do you think about this laser navigation idea? Maybe, as I said, maybe it's stupid, maybe someone already did it and abandoned it because it doesn't make sense, I don't know. But for me, as I'm trying to learn as much as possible about the machine learning and Xcode and everything, and as I had this new laptop, I was thinking, okay, that can be a nice project to try out, even if nothing will be used for anything really. I think can be cool just to try it out, as it's nice playground example. And well, what time we have? 20:42. Okay, so within 5 minutes we will get the results, so we can try it. Good. Well, yeah, as I mentioned, I would like to try not this. I want to delete this. As this is running, I cannot probably. Can I? Yeah, new project. In here is the style transfer. Oh, I know what's that. Transfer an image or video to adapt the visual style to reference image. This can be interesting to try. Action classification. Classify a person action in the video clip based on their body movement. Okay, that can be interesting as well. So if someone's running, it can tell someone's running, and someone's walking, then it will tell someone's walking. Okay, that's actually pretty cool. Activity classification. I can imagine that will be more or less similar. Motion sensor data. Okay. Capturing motion sensor data. Okay. So basically, this can have, for example, access to the gyroscope and tell, for example, if you are running or not, or something. Okay. Sound classification. Classify the dominant sound in audio clip. That can be useful. I don't know if there is barking of the dog, probably it can find out within the audio. Okay, text classification. Classify the dominant topic, theme, or sentiment in natural language text. This can be used for like spam filter or something, I can imagine, or no idea to be honest. And for tagging, split natural language text into classified phrase or word taken based on the no idea what's that again, but I will find out. And all of these three, this is for the tables. That sounds boring, but can be pretty interesting as well. Well, if I never tried to open this, but let's try quickly. I have no idea how to use this, to be honest, so I'm not going to do it now. I will just play it with myself first, then we can try next time. Meanwhile, this is almost done, so let's just wait. And also I wanted to ask you if you think it's better to use the YouTube live stream like we did last time and now, or do you prefer these 8x8 calls, like Zoom-like calls? Because I don't really mind, but with this it's kind of easier for me because I can use the OBS and switch between the phone and my screen and the camera and everything. But if you prefer to do it another way, we can try that next time. Just just let me know. Okay, so we are almost there. 960, 965, 970. Okay, that will be fine. Oh, I just figured out Michael B in the chat is my brother. Oh, hello. Yeah, I feel so stupid. Okay, and here we are. We are done, so we can try. Actually, what I'm thinking, this may be even more accurate because it's based on already pre-trained model which has more images than 10. So okay, let's try which we do these boards. but not boards, but new folder with items. Yeah, these are the boards I took pictures of. Okay, this is exactly what I didn't want to happen. It just threw away tons of classes and they are even all wrong. So okay, so this is just huge fail. Christ. Okay, so this is total fail, and this is probably because of the really poor data set, just 10 images, and we use transfer learning for this. So as I said, that's why I prefer to use the full network training for something what is not so usual. But I mean, we can try to use it with the phone, but I believe it will be terrible. Boards number 2, and I'm going to try it. Boards number 2, here we go. And boards number 2. Good. Run to my phone. And once it will be ready, I believe the result will be totally terrible. Oh, sorry, I killed it. Okay, good. Yeah, as you can see, it's not recognizing anything. As expected, really, but yeah, nothing at all. But with these 10 images from full network training, it was recognizing quite well. Yes, the bounding boxes was off, but it was recognizing it well. So there we go. Actually, this one I wanted to show you. This is the difference between the transfer learning and the full network training, depending on what are you doing. So that's actually quite good example after all. So I showed you after all the difference between transfer learning, and again, the transfer learning will be great if I probably just add more images, like 100 per class at least or so, because 10 images is really not good enough. But now I just realize maybe within 1 minute I can try, just for fun, image classification, and then that's probably enough to have just 10 images. So 1 sec, it will be not long. I'm going to copy this, boards copy, let's say, okay, and I'm going to remove all the annotations because we don't need them for classification. Move to bin, and so these 10 images, let's call this motor board. Of course, it will not tell us the position, but it will tell us what it is. RPI. Okay, and now I believe we just need to do this. No, 1 second. I need to remember how it was. Yeah, there we go. And just hit the train button, and this is just the classification, so this should take just a minute or less. Oh, that's done. Okay, so that's done. It took like a second, and I'm going to let's try some New folder with images. Yeah, so let's try all of this. And it can tell us when Raspberry Pi, motherboard, Raspberry Pi. Oh, of course, because image classification cannot tell when there are two objects, so it's not fair for me to show it like this. So motherboard, Raspberry Pi, motherboard, and Raspberry Pi, and this is not relevant. So here you can see really the image classification is much easier to train because it doesn't need to tell you where exactly this, and as you see, it trained it like in a second or so, and after just 3 iterations, it's 100% sure. And I think that's pretty awesome. And that's just 10 images per class, so we can, just really quick, because it's almost 9, just really quick, we can try to run the example for the image classification. So Apple image classification, I think there was example with the flowers. Yes, just download this project, done in a second. Okay, I'm going to close this. Oh no, I didn't want to close that. I want to reopen it, my image classifier, and I want to output get, or shouldn't I already, I don't remember if I saved it or not, my image classifier. Okay, now I can close this, open this project. Word, I mean, maybe I should rename it. How's the file training CreateML model? Okay, so this is the one. Remove, open this in Xcode. Trust and open. Okay, so here we go. I just change this to my name because it will not allow me. Okay. And in second, we can do my image classifier. So maybe I should name it boards or something, but whatever. And here or here or here, I never know. Somewhere in here, I will change the name and we are good to go. Here. Because this is ML model, so I'm going to change this, save, put it on my phone, and we will be able to see how well it will recognize the Raspberry Pi and this motherboard. But this is just the image classification, it is not going to tell us which one. Oh, I messed this up, 1 second. I hate this because Apple always, if you don't have the premium developer account, it's just, wait, I need to remove this app, 1 sec. Okay, maybe now. Yeah, so now I'm going to show you my phone. Okay, and now, as you can see, oh, I forgot one thing, sorry. Not in here, but in here. We need to change also the info.p list. Not this one. No. Oh, here we go. So all of these we can just remove. And there was motor board, I think, and no. RPI. And also we should put some pictures in it. So I can do from like this, and some Raspberry like this, put it in here. Okay, so RPI .jpg and motor board. Okay, all of these we can remove because we don't need them. Delete. I hope I named them correctly. Motorboard and label motor board. This is a motor board. RPI. This is a RPI board. Now put it on my phone. And if I name them the same as the folders, what I believe I did. Oh, without. Okay, so like this. And also this I need to rename like this. Good. Now let's just quick update and we should be ready to go. I'm going to show you my phone. And here we go. So Raspberry Pi, boom. Motherboard, boom. Motherboard again. Raspberry Pi. So this is working pretty well, but again, this is not object detection, this is just image classification. But it's working as magic, as you can see, and it was trained in 5 seconds just with 10 images input, and that's crazy, right? Okay, so that's all from me today. It's 9 o'clock exactly, so that's pretty cool. Let me know what did you think about this, and hopefully you understand what I was trying to say, because I was jumping from one thing to another as always. And see you in 2 weeks then, right? Yes, 2 weeks. So it will be 18th of February, if nothing will go wrong. I hope not. Okay, so thank you, Rob, and everyone. See you next time. Bye bye.